Okay, an electron gun, as you can see right here, is a series of metal plates and rings and other plates, and they're used for producing a beam of electrons that can travel in a straight line through a gas or through a sample, and then you can detect what happens afterwards. Now, the first thing you need for an electron gun are electrons, obviously, but the best and easiest way to get those electrons is through thermionic emission. It produces an electron cloud of roughly the same energy, give or take 1 or 2 electron volts. And thermionic emission is when you heat up a metal enough that the electrons inside gain enough energy to overcome the work function and they can leave. So you can see here this little metal wire. It's kind of the same as a tungsten filament in an old light bulb. And you produce thermionic electrons by heating them up with a current, and then they jump off the end of the wire and they hang out in a cloud. Now, the next step for an electron gun is to accelerate that cloud of electrons, and you can do that by applying a voltage to this cylinder here. Now, this cylinder has a flat top with a hole in the middle, so when you apply the voltage and you want to apply, positive voltage to attract the negative electrons, they are then accelerated through the hole from the cloud above our pretty wire there. Now, this next plate is grounded so that when the electrons leave the hole, they are they are attracted through the hole of this grounded plate. So you've then got electrons with the voltage and energy that you applied to this cylinder here. And typically for my work, where I look at electron interactions with biomolecules at low energies, I give them between 500 and 1500 volts just to zap them right through. Now, once you've got your electrons, you need to focus them somehow, because you want your beam to be nice and tight and small and traveling in a nice straight line. So these 3 cylinders here are for focusing. The first one and the last one are always grounded. That way you don't change the energy of the electrons as they travel. This one in the middle, however, you can apply a voltage to, and that focuses the electrons in a way that I will describe later because it's quite complex. But what you need to know now is that you have a grounded part, a part that you can apply a voltage to of what you like, and then another grounded part so that the electron beam is focused as it travels through, but it doesn't gain or lose energy, which is really important. Now, these things here are deflecting plates, and you'll see that they're actually the same. There's 2 plates that are facing each other, and with both of them, you ground one and you apply a voltage to the other. Now, the voltage you attach to, say, a variable resistor so that you can change the voltage while it's inside the system to whatever you want. And that is because these are deflecting plates, and they are used to deflect the beam to where you want it to go. Now, if I was an electron, and I, of course, am charged, I've got a negative charge, and I'm traveling through this vacuum looking for something to do. I've just been focused by these 3 cylinders, and suddenly I come across this electric field here, which goes from 0 to whatever voltage you apply. Now, because I'm charged, and I'm moving through an electric field, my path is deflected a little bit. And since I've got one set of plates in the X direction and one set of plates in the Y direction, I manage to deflect my beam exactly to where I want it to go, which is great because typically the holes into the interaction chambers or into the spectrometers for my work are about 1 millimeter or 2 millimeters, so I need to get my electrons from my lovely tungsten filament all the way through this apparatus, and then typically a distance of, say, 10 centimeters, 20 centimeters, and get as many of them as I can into a very small hole. So these deflecting plates deflect the electron beam in 2 directions so that I can get it exactly where I want to go. So to recap, electron guns typically have a filament made of tungsten because the work function of tungsten is appropriate for thermionic emission, and then you've got an accelerating cathode, which you apply a positive voltage to attract the electrons that come off of that tip. and then you ground this plate so that the electrons have a reference for their acceleration. After this acceleration, they go through these focusing optics, and this is grounded. This you apply a voltage to, this is grounded. The voltage changes depending on your system, and that helps just tighten and focus the beam. These are the deflecting plates, and they're used to change the direction of your beam so you can shoot it at whatever you want and hopefully detect something going on. I don't know what you're looking for, but if you can detect something, good on you, because electrons tend to have a life of their own. Thank you very much.